guys, it's Cliff here from Down Under. Right, on the impact tolerant touch probe, part 9. I'm assembling up that run of 50 odd parts that I've been making in recent weeks, if you've been following me. And I've got a bit of an assembly showcase to show you guys them going together, and I'll break the video in the middle with a bit of a setup and accuracy check, just a quick one. Alright, I'll get on with it. Well, here we are. I'm beginning assembly now of the Hallmark ITTP, the run of parts I've been making over recent weeks. They've been going really well. They're all assembling up and going 100%, and also all the probes that have been supplied around the world to date have been functioning 100% as far as I'm aware. I've yet to have any negative feedback. So this is the final stage of the run of 50 odd parts I've been making in recent weeks, and I'm just doing the assembly of them now. So just a bit of a showcase here of the assembly. Lots of shiny parts for us hardware junkies. I've gone to gold lettering. I don't know if that's a good idea or not, but anyway, on this particular run of 50 parts you'll be able to recognize them from the gold ITTP. For those of you that are new to my channel and to the Hallmark impact tolerant touch probe, I should do a little bit of an overview or a little bit of history. I'm a tool maker and I manufacture components and parts. That's my main business, and this has just been a little sideline project for me over the last couple of years, and I've only been able to fit in R&D and design and development and production of these components in between jobs on my main income, which is the contract parts and tool making work. And so my ability to manufacture large numbers is obviously limited, and my ability to deliver to meet the demand is obviously currently limited. And so it's not a highly commercial business with a website and mass production. This is a kind of an enthusiast engineer's project at this stage that I'm really enjoying, and I'm enjoying sharing the journey with you guys on YouTube. Well, the journey started back in 2015 when I bought a low-cost touch probe, and I did a bit of a study of it. If you look at my YouTube channel Thread Express, back in 2015 I bought a Hallmark SPU 40 touch probe, and did a series of videos studying this probe and trying to understand what were its good and bad points. How accurate was it? How reliable was it? And so on. And that was a really important background to this development project. And in 2016 I decided I would try and develop a probe that had some of the or all of the advantages of the low-cost touch probes, but try to improve on the disadvantages. And if you look at that video series, you'll see some of the disadvantages. I don't really want to be negative here, but just touching on it briefly, they are inclined to be unreliable and not very accurate, and obviously they're not impact tolerant. So I want to develop a probe in 2016 that was impact tolerant, reliable and accurate, and that was quite a challenge. I mean, it was a fascinating challenge, and it took me many months to come up with a winning formula. In fact, it wasn't until December of last year, December 2016, that I actually found a winning formula that was reliable, impact tolerant and accurate. And so in February 2017 I began to ship out some of the early versions of these probes. I tested the probes that I built in December 2016 for about 2 months, and became more and more confident that there wasn't a problem with them. And in February I began to ship them out to various receivers overseas who have been using them, as far as I'm aware, without problem since then. So that's several months of use now. So I'm feeling very confident now about the prospects for this product. So you might be thinking, where to from here? You know, if you're going to run your parts and tool making business, you're just not going to have enough time to manufacture enough of these probes to meet the demand. And yes, I recognize that is a problem. I have to make some decisions now, but I hope that I can continue to manufacture these probes long term, because it's such an enjoyable product to make. I mean, every single component is an enjoyable part to manufacture. I couldn't come up with a more enjoyable product to make, and so I want to at least make these probes in small numbers long term. That will be at least part of the manufacturing supply line. Here I'm only videoing the externals of the ITTP. I want to retain some of the intellectual property of the critical internals at this stage. So getting back to the supply situation, I know some of you are interested in that. My ability to supply is currently limited. Long term, that's likely to change. If you want to contact me in the short term, feel free to email me, cliffhalldesign@gmail.com. You can find that email address in the Thread Express channel under About. Well, I've been waffling on a bit there, haven't I? So just to break up the video, I'll do something a little different for a couple of minutes. I'll do a quick setting of a probe, concentric, and test it for accuracy. And that'll be a little bit of a break for you guys that are tired of me rambling on. All right. Okay, let's go into setting the Stylus concentric. You should find it a fairly quick and simple procedure. There's just 3 adjusting grub screws here at the top. So we bring our indicator needle, these are 100ths of a millimeter graduations in the style indicator, into contact, and note the direction the needle's going with more engagement. So it's going in a clockwise direction when there is more engagement. Now we'll rotate it and see the extent of the run out. So we are approximately 2/3 of a revolution of the dial, quite a long way out. Okay, so let's go to our most anti-clockwise position, which is about there, and we will adjust screwing in. You see that okay? About half that amount, and then back that grub screw off again. We don't want it to interfere with the adjustment. Now let's see how far out we are. We're now within approximately 0.2. So let's go to our most anti-clockwise position, which is there. And we're going to make an adjustment now of about half that amount. Requiring adjustment there. Now it's pretty true. You can see now you're getting a little bit of a flicker of the needle. It's approximately half a hundredth out. I won't try and get it better than that on the video because it's a bit awkward to get at with the camera going, but you just finally snug down those screws until you get it as close as you can. And you can never get it perfect because a change in direction and the flex of the stand of the dial indicator, any errors in the dial indicator, especially if the little stylus is loose, check that's tight. You'll get all sorts of difficulties if you've got looseness in the stand or in the needle. Okay, now we'll use the probe and test it for accuracy and repeatability. So I've got in there a die test master bore gauge of 800 thou, accurate bore, and I'm just going to probe using a probing routine to find the center on G54. Quite a slow probe at 800 millimeters a minute. And now I'll go to G55 and set a separate work offset. Go back to the probing routine and run it again. And that finds the center and sets the work offset for G55 as we have just done with G54. So here we are with PathPilot on the probe page. Find the pocket center. We're going to use this probing. We have just used this probing routine, so it finds the part center and sets the XY 0 on G55. So it's still parked there where it had found and set its center on XY 0. Now if we go to the previous probing routine, which was G54, and enter that back, you can see here the relative difference in the position between one probing routine and the other, and it's 2 microns different in the X and 3 microns different in the Y. That's very good. That's less than 1/10 of a thou difference in the repeatability between the probing routines on 2 different work offsets. Okay, so carrying on with the test, we've now put a dial indicator in there. A dial indicator that has got the dial at right angles to the stylus so it doesn't go out of view. And we've set it about the same distance down as the probe. Yeah, it's pretty close. Obviously if the head's slightly out of square or the vertical slides slightly out of square, you would get a difference if the probe length was a different length than the dial indicator length. So this is relatively similar. Okay, so we've got a dial indicator in there and we're still positioned over the XY0 that we set with the probe, with the last probing routine. Now remember that probe was only dialed in quickly with an indicator on the end to within about 1/2 of a millimeter. We're just doing a quick check here to check that it is within the sort of range we need. Okay, so we've come down into the center of there and we're going to rotate the dial indicator and see how concentric it is. And this is a mechanical method that's going to be a much more direct line of checking and have a lot less variables in it than using a probe or a Hallmark, because you're rotating it. And if it's 1/100th out, it'll show 1/100th of a millimeter movement of the dial. Obviously it swings to the plus 1/100th and to the minus 1/100th. And you can see there it's about 1/100th of a millimeter total swing. So it's showing a position discrepancy of about 1/100th of a millimeter. That's about 5 microns. So that's very good. For general workshop use, that test shows repeatability that's very acceptable with that quick concentricity test set up with the probe. If I set the stylus slightly more accurate, I'd get better than that. But within 1/2 within 5 microns, that's 1/4 of a thou approximately. That's more than good enough for almost all of the type of workshop use that the probe is intended for. So you can see from that quick test of setting the probe approximately concentric that you can work within 1/2 thou really easily and quickly with the probe. Now obviously you can set it up to do more accurate work than that, but I would question whether it's worthwhile. You've got to remember that these low-cost machines are not highly precision. there's all kinds of errors in them. There's errors in the concentricity of the spindle taper, the TTS system, the collets, the squareness of the head, the backlash in the X and the Y and the Z, the stiction and friction and momentum errors, lost motion, twisting of the castings, give adjustments, all of those various factors all add several minor errors to the equation, and I go into this more deeply in previous videos. If you look at part 6 on the impact tolerant touch probe, I go into those subjects more deeply if you've got an interest in it. But just generally speaking, you can't hope to achieve micron accuracy in a machine that has 10 or 20 errors, minor errors that can all compound to, you know, a thou or two's error quite easily. So just keep that in mind. You've got to be realistic about what these machines are. And if you're new to this product, to the impact tolerant touch probe, I go through a lot of its technical features in previous videos. If you look, you'll see a series of videos going from part 1 up to part 8, where I go into such subjects as accuracy, impact tolerance, and reliability. I can't cover that all now in a summary, so please just have a look at those existing videos. YouTube videos like this are an ideal way to document the development of a technical product, but it's not an ideal format for discussing business matters, quite apart from normal business confidentiality requirements. Any subject that was discussed would soon be outdated because the video is fixed in time. So I hope you understand that I've kept these videos on the subject of technical matters. All the same, I've touched on this subject because I know some of you are interested, and I imagine some of you are wondering, why does it have to take so long to get a product to market? And I've been involved in product design and development for decades, and I've seen many products and businesses come seriously unhinged by rushing this stage. And I'm really confident that progress, in order to be successful, must be slow and methodical. You know, you talk about R&D, just 2 letters, but they are so critical. You should really be R and R and D and D. Research and reflection, design and development, and then back to research and reflection, design and development, until you've got all the little crinkles ironed out. If the product is not 100% resolved and mature technically, it won't stand the test of time. And 19 out of 20 new inventions that are brought to market, the statistics are 19 out of 20 fail. So, you know, I'm very aware of the need to be methodical and patient. One of the reasons the impact tolerant touch probe has been such a slow development process is that I've had an agenda of striving for the highest quality design I can. That's just my interest in life, is high quality design. And I've been doing long-term tests of different component materials. For example, I don't want to disclose everything, but this is a good example. The Stylus tip ball, essentially a 4mm ball. I've been trialing different grades of balls, different grades of steel and hardnesses and so on, and doing overnight water tests and salt water tests and charting out the results, and really finding what is going to perform the best. And if you look at that over all the different internal materials of the probe and how they relate to each other, is quite a big development process. But the end result will be not short-term profits, but a long-term excellent product that should have a good reliability reputation. Well, that's enough, isn't it? Thank you for following me on this again, guys. Catch you later.